This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 148. Hope your summer is off to a good start, meteorological summer that is. The title of today's presentation, Monitoring the 2023 Alaska Spring Breakup, LEO Satellites, River Watch Flights, and Citizen Science. Our presenter is Jen Delamere, Director of GENA at the University of Alaska Fairbanks. Our discussion after the presentation will be facilitated by Gerald Torres, Research Associate and JPSS Satellite Liaison from SIRA in Fort Collins, Colorado. Just a few reminders before we get started. As you just heard, this session is being recorded. There will be an opportunity for Q&A after the presentation, and if you have signed in with a office account, please make sure you're specifying your full name when asking a question. That will let us get back in touch with you if necessary. And of course, we will take questions from the chat, but if you'd like to ask a question verbally, please indicate such, and you can certainly engage in that manner. Also, please remember to check your spam folders, as the email system for NOAA may be occasionally rerouting TOWRS communications there, and we'd hate to have you miss a Satellite Book Club seminar. We're always looking for future presenters. Please contact our TOWRS team, Krishad Bowman and Emily Maddox, if you would like to present. And just a reminder, it does not have to be directly related to satellites. Perhaps satellites were part of a broader forecast challenge that you'd like to share with your colleagues. We'd love to include that presentation as part of our seminar series. The training team can help create training materials that may be unavailable or you may be unaware of. Brian Mata, the Office of the Chief Learning Officer, can field your questions on that. I'd like to thank the TOWRS team, particularly Krishad Bowman, Lee Byerly, Emily Maddox, the Office of the Chief Learning Officer, the GOES-R and JPSS programs, our facilitator, Gerald Torres, and all of you for being with us today and your support of the Satellite Book Club. Without further ado, I'll be shortly turning it over to Jen, who studies the Arctic environment from the ground and space. Her research focuses on precipitation measurements and the spring melt in northern Alaska. Jen is also the director of the Geographic Information Network of Alaska, or GENA, an organization delivering direct broadcast satellite products to Alaskan stakeholders. Having held jobs in the software industry, academic research units, and self-employment, Jen's career path has been anything but traditional, but she wouldn't have it any other way. Jen is a repeat presenter here at the Satellite Book Club. Glad to have you back.
Thank you. Can you hear me?
We hear you. Perfect.
And you can see my slides.
Yes, we can.
Okay, fantastic. So the title of my talk today is Monitoring the 2023 Alaska Spring Breakup, LEO Satellites, River Watch Flights, and Citizen Science. So when Lee Byerly asked me, I don't know, 6 months ago, if I'd consider giving another presentation of the Satellite Book Club, I decided to say yes. And I decided to bring the true spirit of the Satellite Book Club or Journal Club forth. That is, I am not a hydrologist. I am not a specialist in river breakup. I'm a purveyor of satellite data. So with that, I thought, you know what? I want to really learn more about what we're delivering here in Alaska for river flood products. So what the heck? Yeah, I'm going to do this talk. So this is the first time I've done a river flood talk, and I couldn't have done it without an extremely extensive team. So I formed my own little book club here in Alaska before this presentation, and all the people on the screen before you contributed to this talk. This is not my own work, and this has been a great experience talking to colleagues around the state of Alaska. So if you've ever heard one of these talks before about Alaska, I'll say we Alaskans love to crow about how big Alaska is. I think Texas, California, and Montana fit within our borders. 665,000 square miles, 730,000 residents, approximately 1 moose per every 2.75 people, and no Dunkin' Donuts. Stats you might not have heard before is that in Alaska, there are only about 18,000 miles of roadway, and something like only 20% of our municipalities are available or can be reached by road. So therefore, rivers are just an extremely important part of life in Alaska. From what I've been able to ascertain, there are about 12,000 rivers in the state, 365,000 miles of river. So, well, what happens in the annual cycle of rivers? Rivers in Alaska freeze, and when they do, we often use them as ice roads. I'd like to show a picture of the Kuskokwim Ice Road. That's a major river here in Alaska. The ice road has reached a maximum length of 355 miles in the winter. But winter must end and spring comes along, and we Alaskans are thrilled when that happens. So in the nicest of ways, spring gets warm, trees get green, the birds start singing, and we would have sunny weather and a gentle ice breakup where the sun and the temperatures are moderate and mild, and the ice breaks up nicely, and that's known as a thermal breakup. However, there is another type of breakup called dynamical breakup, and this is the type of breakup that makes the news. This is where the river breaks up, perhaps under extreme conditions of high snow, cold temperatures that turn warm really fast. The river ice melts, it breaks into gigantic chunks, it flows down the river, it jams up, creating overbank flooding, backwater flooding. It's really, quite something, and it's what you see on the news. In general, in Alaska and probably most places, most breakups are a blend of dynamical and thermal. So how do we watch over these 365,000 miles of waterways or rivers here in Alaska? Well, I would like to call out the incredible Alaska Pacific River Forecast Center, one of over a dozen river forecast centers within the state of Alaska. This group of hydrologists working with the WFOs does an incredible job. So if nothing else from my talk, take down this web address, weather.gov/APRFC. There's an incredible amount of information on their website, and their hydrologists are always willing to talk. They look out for our safety, and they provide the communities in Alaska plenty of information to prepare for flood season, and they're always out in the community. So again, this website, I encourage you to visit it and learn all about what they do. In order to do their job, however, they need to consume vast amounts of information. So this slide doesn't even begin to address probably everything the hydrologists and forecasters at APRFC consume. But what I'm going to talk about today are three distinct pieces of information that APRFC uses when producing their breakup forecast and getting information to the community. So as my title suggests, I'm going to talk about LEO or low Earth orbiting satellites, aerial imagery, and citizen science. What I won't really be addressing are the extreme importance of ice gauges, ice thickness measurements, and historical and climate data. So with that, I'm going to move on to the first of my topics. So low Earth orbiting weather satellites. So I call them weather satellites because there's really tons of low Earth orbiting satellites, and I'm only going to talk about a few today. So here in Alaska, as you've heard in these satellite book clubs before, we use these low Earth orbiting satellites because they have high pass frequency and high latitudes. There's a multitude of satellites available that we can use to do weather forecasting and river forecasting. And with the satellites that I list here, from the NOAA series down to MEDOPS and Terran Aqua, we can get resolution, spatial resolution as great as 375 meters. The image on the right side just shows a selection of 10 satellites, LEO satellites, that are important both in flood prediction but in weather forecasting as well. So LEO satellites are a way that we can see the 49th state in its entirety. So if LEO satellites are how we see Alaska, how do we actually receive that data? So this is my job, actually. I manage a direct broadcast facility here at the University of Alaska Fairbanks. What does this mean? This means we have two antennas. In the left top image, you can see a radome. That's an antenna we affectionately refer to as Big Dog. The lower right is an antenna located at the NOAA FCDAS facility, affectionately referred to as Sandy Dog. These two antennas are moving around the clock. We're receiving 10 polar orbiting or LEO satellites on them. We process the data in near real time using the incredible CSPP software developed at SIMS. And the real key here is that this data in these products are going out to the community within 15 to 30 minutes of the end of an overpass. So this is an incredible opportunity here in Alaska that we take advantage of because of our high latitude. Just so I don't have you think that what we do here at the University of Alaska Fairbanks is the be-all end-all of LEO satellites, I want to point out that the satellites that I just talked about have high frequency. They're frequently passing over Alaska. There's a 3,000 kilometer swath length for VIIRS. But there are other really important LEO satellites. For example, Landsat and Sentinel-2. Sentinel-2 channels have a spatial resolution from 10 meters to 60 meters. They're incredible ways to view the surface here in Alaska. However, they don't have as great a frequency. So what you really need is the pairing of these satellites. And I think that the 12 satellites represented here are a great path forward. So now I want to highlight a product that you've heard about before. William Straka, who's on this call, has in fact given presentations on the NOAA VIIRS Flood Mapping product. What's different about my talk here is we go a little bit further and we show this product in the context of some other measurements. So the VIIRS Flood Mapping product is incredible, and in the spirit of book club, I don't know if you can see my camera, but I've been reading lots of journal articles on this product. But here's the highlight of this. This product at 375 meters spatial resolution allows each pixel to be classified in the percent flooding for each pixel. And speaking with Crane Johnson, the hydrologist in charge at APRFC, he wanted me to point out that that's a real highlight, the ability to not just see that an area is flooded, but to classify each pixel with a percentage, or to talk about overbank flooding. There's just a lot of information that can be gained from this this product. And what I want to point out here is this product is a 10-year history that started in research, went research to operations, and is now operational. And the panel on the right is a social media post from the National Weather Service, and you can see the inset of the VIIRS Flood Mapping product. So just a few weeks ago, on May 16th, 2023, you can see that APRFC was really using this VIIRS product, and they have so much confidence in it that they're using it to promote flood watch. And I think this is an incredible testament, and the reason why I wanted to do this book club is that I learned myself about a product that we are providing here from the University of Alaska Fairbanks to the National Weather Service. And I think everyone that has participated in the development of this product should be very happy with how it's gone. But satellites can't see everything, particularly in the presence of cloud or shadowing. So a very important program is called River Watch. It's an aerial program where it's basically pilot's eyes over the 49th state. So APRFC uses a lot of aerial imagery in their forecast warnings and river navigation. Some flights are scheduled with to fly over the Yukon and the Kuskokwim, but there's also opportunity for pilots and village residents to report observations of river ice conditions. So if a pilot wants to call in and file a report, they can share their visuals and their experience, and this has improved incredibly useful in APRFC's ability to forecast and provide warnings. But I want to take it one step further. There's an opportunity for citizen science here in Alaska and riverways. And I want to commend the Fresh Eyes on Ice program at the University of Alaska Fairbanks for recognizing that there was a need for satellite imagery, for aerial imagery, and really from input from residents. So the Fresh Eyes on Ice program here has sort of three tasks ahead of them: to support education on ice science and safety, to foster communications and monitoring of ice conditions, and to conduct scientific research. And I want to talk a little bit about feature 2 here, especially in the 2023 flood season. Citizen observers used a myriad of different technologies to upload imagery and observations of what they were seeing. And again, referring back to a little snippet of information Crane Johnson at APRFC provided me. He said, you know, satellites are great. You get these polar orbiting satellites or LEO satellites are great. You get these snapshots of the ice. And if you have a lot of clear sky, you can see how the river conditions change between passes. But what citizen science allows you to do is to get input from the people on whether that ice is stationary or whether it's really moving. And so for APRFC, Fresh Eyes on Ice and other citizen science initiatives are really an incredible way to sort of connect the satellite data to what's on the ground and what's coming. So from the National Weather Service, I want to now talk a little bit about the 2023 Alaska Breakup. This was a slide provided to me by APRFC. There are 3 components that are heavily considered for breakup: how thick is the snowpack, how thick is the ice, how strong is the ice, and what are spring weather patterns? Is it cold? Is it normal? So in April and early May, the APRFC could see full well that the snowpack was deep, much deeper than normal, and that it was persisting. So in April and into early May, you had a deep snowpack with a high snow water equivalent. On the left side, you could see percentages in April. Those were percentages above normal. So the SWE was up to 150% higher than normal. By May 1st, you can see that the snowpack was extremely high compared to average, 338% for interior of Alaska. Temperatures were also super cold. So from the ERA5 analysis, you can see that through April, we were well below normal across the entire state for the most part. So it was a really cold April. There was no warming up to be found. So APRFC also looks forward using these really incredible maps from the Climate Prediction Center. So at the end of April, they could see that it wasn't going to get much better in early May. It was going to be cold. So with all this information, the APRFC made the prediction that this year, 2023, was going to be heavily tilted to the dynamical breakup side. So this is the ice jams and potentially big flooding events. And it was going to be later than average. And APRFC did a great job doing this. And I was told that in part because there's just so much great information now coming from the Climate Prediction Center and all these other sources of input. So in fact, breakup has been late this year. 6 days late on the Yukon, 10 days late on the Kuskokwim, 2 major rivers in Alaska. So I'm going to just, in the next 5 minutes, take you through some snippets. If it looks like I'm going to read some material, that's in fact true, because there's some great publications and notes from the APRFC on what happened. I'm going to concentrate on one river this year, the mighty Yukon. The Yukon is 2,000 miles long, over 1,300 miles of which are in Alaska, and it's a huge part of life here in the interior. So this year's flooding season was the story of ice jams and freshets. Now, what's a freshet? I actually didn't know, and I learned this as part of the Satellite Book Club. A freshet is a commonly described snowmelt, annual high water event on rivers resulting from snow and river ice melting. So that's a great word to add to your vocabulary if you didn't already know it. So where did this flood season start? On the Yukon, I'm going to start describing things in Eagle, which is just east of the US border. So this is an image. I'm going to read a headline. 40 miles just east of the US border, the oldest town in the Yukon almost wiped out by ice jams and flooding. This is a picture from a photo looking at the confluence of the 40 Mile and the Yukon. From the Riverwatch team, there was a large ice jam here. And Crane Johnson at the APRFC let me know that it was this event that knew it was going to be a tumultuous breakup. So on May 11th, 2023, I just want to show a quick VIIRS image. It shows that the cyan here is ice. There was lots of ice as we moved into the United States over the town of Eagle. This is May 11th. And on May 12th, there was breakup. There was a large ice jam in the upper Yukon with stationary packed chunks of pan ice. The downstream toe of the ice jam was 30 miles long upstream of Eagle. By May 12th at 4 p.m., the ice was really moving. I'm just going to show a little video. And there is a swear word coming.
Oh, Willie, look at this shit. That's what I'm doing, man. Wow. Uh-oh. That ain't good shit. Sorry.
So Eagle was pretty exciting. Ned Roselle published an article called When River Breakup Comes to Alaska, in which he basically illustrated that in the dead of night, the river had thrown its strongest punches. This is just another image. And on the left, there's just flipping back and forth around the village of Eagle again, pre-flood, post-flood. So moving down the Yukon, we come to Circle. And Circle was quite a case this year. This was considered a catastrophic flood event. By the 13th of April, there was a breakup front that had a 90-mile run of ice extending 5 miles upstream of Circle and for 90 miles, the longest ice run the Riverwatch team had seen. There was no clear path of the ice downstream of Circle. And you can see on the bottom that I quoted fresh eyes on ice observers that while all this was going on and there were flights and satellites, people on the ground were reporting observations. The governor of Alaska declared a disaster declaration because the flooding was so significant. And the left are some snippets from the river, some river notes from the APRFC showing that on the 13th, there was major flooding, and by the 14th, the flooding had started to recede. And I just want to show that in the middle panel here, this is a VIIRS image, and you can see the pixel by pixel approach that VIIRS has at 375 meters, where you can really see quite a few details. Next stop up the river is the Yukon. On the left, I just want to show, this is a GIF between Dayland Cloud RGB image from VIIRS and extensive flooding that was going on between Circle and Fort Yukon. That's about 80 miles apart. So even though breakup had finished in Circle, there was a lot of activity between Circle and Fort Yukon was preparing. So on May 14th, the water was very high in Fort Yukon, and let's see. On the right side here, you can see a comparison between VIIRS and Sentinel, and as William Straka pointed out, that there's a lot of moistening along the creeks east of the Yukon, and this gives confidence that the VIIRS flood product is doing well against Sentinel. And the value of VIIRS, of course, is also seen on the left, where you're having pass-by-pass VIIRS river flood products. So moving down the river, past up to Fort Yukon from Circle, the river kept moving. There were very long ice jams, lots of activity, but we did have a period of cloudiness here. So the data from VIIRS is a little bit pixelated. This is a composite image from May 23rd. So the activity happening here is, the takeaway is that the ice was running and snowmelt flooding was all coming together, not quite at the same time. A little fact I learned through this presentation is that typically there's about 3 weeks between when the ice runs and when snowmelt flooding happens. But the story of this season is that the ice run and the snowmelt flooding were almost happening simultaneously. So Russian Mission was another place, so we're going further west on the Yukon where there was, significant issues with flooding, and this is really where ice jam and snowmelt collided in this community. So on May 22nd, just to catch you up a little bit, observers were calling in to report that the ice was running at Russian Mission. On May 23rd, 7 homes had been evacuated, cabins were off their foundation, and the water level was rising and falling. At one point, it dropped 2 feet in a day. So this is more imagery from Fresh Eyes on Ice showing the impact on Russian Mission of the flooding. And this is another look where we can utilize the full power of LEO satellites. So on the left, we have VIIRS composite products for Russian Mission, and on the right side, we have snowmelt imagery, or we have imagery from Sentinel. In the red circle is Russian Mission, and this slide basically highlights when forecasters can look at both this. You see great justification for what VIIRS is seeing, and essentially we're doing a really good job in a very difficult situation. You can see around Russian Mission the red pixels just indicating there is a lot of flooding. Just some other close-ups from Sentinel showing the Russian Mission airport right in the center of the screen, and an overlay, not to scale, of the VIIRS pass from the afternoon of the 23rd. So I've gone through a lot here, but I want to show one last piece about the breakup season. So the river, it's hugely active from May, beginning of May, all the way to late May. And this image is where the APRFC, the River Forecast Center jurisdiction, meets the Alaska Sea Ice Program shores. So this is a radar sat image from where the Yukon River meets the Bering. And what was really interesting this time is that there was water coming down the Yukon and there was still shore fast ice. So in this case, APRFC and the Sea Ice Center were working together to come up with good forecasting for the communities of Emanock. And I'm just going to pivot back and forth on this radar sat image. So you can see channels of ice, channels in the ice generated by breakup water coming out of the Yukon. So let me just pivot back and forth. It's pretty incredible. So that was a very short tour of the Yukon flood season. I'm going to just show you now that we're winding down flood season. There's still some flooding in the north. What I want to point out on the right side is a time series of Alaska Pacific River Forecast Center breakup maps. So we're about to pivot and I'll let you watch it through. So it's starting now. You can see this is shown to the public. It's put together from a lot of different information. It's an incredible time series of the major river breakups in Alaska. Okay, I'm almost out of time. Somebody wants to come back, I will, because there's a lot more uses for VIIRS. But I want to show that, I've passed on a lot of information today, some of it organized, some of it not. But if you're interested in learning more about the flood seasons here in Alaska, I wanted to point out a number of places you could go. So the GINA website has a lot of links to direct broadcast imagery. VIIRS River Flood is often shown through access through SSEC's Real Earth Viewer. I would like to comment that the social media coming out of the National Weather Service in Alaska is incredible, and citizens all over the state use these social media posts to guide their daily activities. I'd also like to share the Fresh Eyes on Ice Citizen Science web app. Feel free to go to their site and figure out how you can, in fact, share observations or learn more about what they're doing. Lots of training material is available for these floods, for these products. On the right, I'm showing a quick guide on the VIIRS Flood product, and Jarrell Torres, who's on this call, has let me know he's updating this quick guide, and a new version should be available in a couple weeks. So for those watching from CONUS, how do you get the VIIRS River Flood product? So I just want to, this is where I'm not an expert, but these products are now being created operationally using the normal NOAA downlinks. The latency is around 90 minutes. It can serve as a direct broadcast backup, and I believe the TowerS team is managing the rollout across CONUS of this product, but they can speak more to that. Finally, there's much more information available from the Real Earth site. There are global, daily, and 5-day composites being created now. This is an image that just shows that from one day, June 8, you can see flooding in the Yukon and flooding occurring in the Ukraine. Again, this is an incredible testament to this VIIRS product. And with that, I'm done. Thank you for listening today to my informal book club. I encourage others to maybe take the stance that I did and reach out of your comfort zone and try to learn something. And if nothing else, share a lot of material with your colleagues.
Thank you, Jen, for that great presentation. And as we transition here to the Q&A, I just wanted to encourage attendees to please stay on for the additional discussion. And we also encourage the participation from field forecast offices, regional HQ, and additional attendees. And we would also want our attendees to specify their full names in the chat when they're asking a question, and also to complete the feedback survey posted in the chat room. I will also mention in a week from today, on Thursday, June 22nd at 12 p.m. Eastern, Eric Luleyet, NESDIS Altimetry Branch Chief, will discuss satellite wave altimetry. And we also encourage attendees to contact the TowerS team, Kashad Bowman and Emily Maddox and John Evans, for questions about the SBC or for configuration of the satellite products. And now we'll transition to the Q&A here, Jen. And the first thing I see here in the chat is from Scott Lindstrom, and that he asks, does a late flood season in Alaska correlate well with a late start to fire season in Alaska? Or is Alaska too big to make a general statement?
Well, I perhaps have to confess that I don't perhaps have the right knowledge base to answer that question. It's a great question I thought about while I was creating this presentation. I will say that for this year, we've had a very slow start to fire season. We've burned only, hundreds of acres, where at this time last year we burned over 1 million acres. I should note, however, in 2022, when we did have that big burn, that we did also have a high snowpack that year, but the temperatures were fairly normal throughout April and May. So I can't make a big sweeping statement, but I think that would be a great topic for another book club. So Scott, I volunteer you.
And as I wait for more questions in the chat, I have a question or two here from myself. And Jen, with respect to the VIIRS Flood product, in addition to our National Weather Service user base, are there any non-NOAA users that employ the VIIRS Flood data in Alaska?
So just one example, the Fresh Eyes on Ice program that I mentioned earlier, we are working with Fresh Eyes on Ice to hopefully distribute the VIIRS River Flood product and sort of build that into their paradigm. Fresh Eyes on Ice is also working on a VIIRS River Ice product with Stevens Institute of Technology. So my goal as the GINA director, sort of the purveyor of this product, is to bring it to the researchers in the community, and I think I'm well positioned to do that with the incredible teams here at University of Alaska Fairbanks. Also, you would see that although the Weather Service puts the warnings out, they have included, as I showed before, the VIIRS imagery. So we're really reaching citizens through social media posts, and that's extremely important here in Alaska, where there's terrible internet. We've just had a big cut in the internet connection around northern and western Alaska. So, you know, cell phone use is really important, and being able to see this imagery through social media has immense value.
Indeed. And I see there's a question from David, and he mentions, can you speak a little bit more about the CAP river overwatch flights? Looks like there's still about 50% of the funding for this program remaining in the fiscal year. Is that normal for this time of year?
This is a question I cannot answer. I would be happy to try to find that out, or maybe there's someone else on this call, William Straka, that might be able to comment on that.
Right.
I am aware.
I say that would be probably a question for APFRC or you know, Crane Johnson and or the or the Alaska Regional Office.
Great question, though. Thanks for asking.
And an additional question for myself is, Jen, do you know how users are accessing the VIIRS Flood product? Whether that be through Real Earth, the GINA website that you were highlighting there, and or in AWIPS?
Well, all three. To my knowledge, Real Earth is really the biggest distribution site outside of what's going to the Weather Service. So I do know that APRFC does even go to Real Earth, where you can get the composite, the daily composites of the VIIRS imagery. We at GINA this year stood up a sort of quick look portal, mostly to make, you know, help us look at the product quickly. That's now publicly available. And then of course, when the products are created here at UAF GINA, we do insert them. We put them out on LDM, and it's picked up by the National Weather Service Alaska region. So I think there's lots of ways. And again, I want to say social media is really important. I think it can't be denied. It's a part of our society now.
Indeed. And I'll just wait another second or two just in case if there's another question in the chat. But as you mentioned, Jen, we are working here at CIRA to update that corresponding quick guide for that VIIRS Flood product, and that should be coming within the next few weeks for users to check out. But with that, I'm not seeing any additional questions. So what I will do is I'll send this back to Jordan for any final remarks.
Thank you so much, Jarrell, and thank you so much, Jen. I always enjoy those presentations from Alaska. Get us to see a part of the country that many of us otherwise wouldn't get to see, and some of their impacts, which part of the Weather Service's mission and focus recently is service equity. So really thankful not only for our National Weather Service colleagues up in Alaska for all they do, but also for GINA for providing this important data to help with that service equity aspect. All right, so turning the page, looking ahead to next week, we're going to have Eric Louliette, the NESDIS Altimetry Branch Chief, join us in the Satellite Book Club on June 22nd to discuss satellite wave altimetry. So if that interests you, hope you'll join us again next week. In the meantime, feel free to reach out to our TowerS team if you have any questions about the Satellite Book Club or the configuration of satellite products. With that, I want to thank everybody for joining us today, particularly Jarrell Torres as our facilitator and Jen Delamere as our presenter, and all of you for joining us. Please take care and have a great summer.